Welcome, everyone, to the Crystal Group Rugged Advantage podcast. I'm your host, Karen Hildebrand, and in today's wrap session, we're going to talk about power. Now, don't worry, not going to grunt like Tim the Toolman Taylor, and I realize I just dated myself there, but for those of you who are familiar with the popular TV character, his constant cravings for more power really captures the growing burden being placed on the U.S. smart grid right now. Not only are we continuously adding more devices that draw more power, we're also incorporating more sources of energy, all while working to prevent the threats to operational performance. So to discuss these challenges and how virtualization can effectively move the energy industry forward are Prithpal Khajuria, Global Segment Market Leader for the Power Sector with Intel, and Phil Carey, who's currently an independent consultant, but previously was Senior Advisor and Enterprise Architect in IT Grid Services with Southern California Edison. Thank you both for joining me from the great states of California and Washington for today's wrap session.
Welcome.
Welcome, Karen.
So, Prithpal, given the broad complexity of the smart grid, can you explain more about what's driving the challenges and the root problem that utility companies are working to address?
If we can step back and look at it, what is changing in the electric power grid? I think a couple of changes are happening. First is more and more renewables, rooftop solar, parking lot solar being introduced into the grid. On the other side, large-scale renewable solar farms and wind farms are being added at generation level. And the third big thing is happening, our demand for electricity is going up. In next decade, all our transportation sector, the cars and trucks, they're going to get electrified. And digital commerce is growing, and the data centers will keep consuming more and more power. And we have a regulatory pressure to go more renewable. So when put all these things together, it creates like a perfect storm or opportunity and challenges to manage the power grid going forward. So from the utilities perspective, how do we address it? We need a new smart, intelligent systems which are easy to deploy, easy to manage, cost less money, and cost less in terms of operation and maintenance cost.
So truly is a very significant shift, both in the scope and all of the contributing factors.
Exactly. Utilities have to find a new way. And the new ways first is that make the substations intelligent and simplify their architecture. The old concept of every time you have to add a new application, put a box on the truck, send two guys to the substation to add an application. That's not viable going forward because we need more insights into the grid. We need to profile each and every substation because we need to understand what is happening on the other side of the grid. In the past, we never cared about it because we did not have the renewables on the south side of the substation. So we need to understand, profile it, and bring the information which is needed into the control center so then we can have a macro level insight in the whole modeling, the forecasting.
Phil, with more than 20 years working in the energy industry with Southern Cal Edison, and with the smart grid challenges and needs for modernization that Prithpal just shared, what steps are energy companies taking, or should they be taking, to achieve this next level of operational performance and efficiency?
Yeah, so some utilities are already taking the initiative and starting to move some of the control functionality out to the substation where reconfiguration, monitoring can take place locally and possibly in the future lead to some autonomous operation. By creating a virtualized system that we can put out in the substation We can provide the control, increase reliability, and increase security while reducing operational cost. Reliability and security is of key importance out in substations. Some of these substations are pretty far away from where we have crews that can respond to incidents. So it's critical that we have these systems remote monitored and managed so that when something does happen, we can respond quickly and concisely to get the problem resolved.
I would like to add a few things, as Phil said. Okay, how they improve security and reliability and manageability. If we have a cluster of rugged servers deployed at the edge, 3 or 5 servers, so in case one of the server fails, no problem. The system will keep running and our system is still running. Now we can plan it to send a person to replace it. The security needs are changing as the grid is becoming more distributed and the more regulation is going to come towards the substations also because grid is getting flattened. Generation is happening on both sides of the grid. So in order to meet those new security needs, you need a flexible infrastructure which can adapt, which can change with time easily. And last important point I like to bring it here is the manageability. With a virtualized infrastructure, as Phil mentioned, it is very easy to deploy new applications. Just create a virtual machine, deploy an application into it, test it for 3 months, 6 months, evaluate all the logs, and when utility feels confident the application is meeting their requirement, they can turn it on. And same goes for upgrading existing application. They can keep the current application running in one VM, put a new version of it in another VM, test it, then at one point when they feel confident, they turn it on, the new one go live, and the old one, they take it offline, but leave it there sitting in case they need. They have a fallback process. Another thing I'd like to add into it, what this infrastructure will bring to the utilities, know the data will be aggregated from the multiple points into a single database potentially. When all the data is aggregated, normalized in a single database, that creates the next step for the utilities to use the analytic machine learning technology to extract more intelligence out of the data, and then they can feed that intelligence into their ADMS system, into their EMS system, outage management system, asset management systems, and so forth to increase overall efficiency, reliability of their business.
Absolutely. And with what you've both mentioned around the flexibility, the cybersecurity, reliability, ease of use, knowing that these are out in remote, Prithpal, to your point, usually limited staffing or unmanned, how does the physical security of these common substation platforms factor into the overall system?
Physical security of the infrastructure is critical from intrusion detection point of view. Utilities have multiple security levels. There are cameras there or other kind of sensors. But still, if in any case anybody opens that box, and then it should send that message to the utilities. And if it is automatically get into their system, that system can correlate that with the open work order. Somebody was supposed to be there at this time for some service, and if not, then that is a flag for the utility that some unauthorized person is trying to access the system. So it builds another level of security which is required for the electric power grid.
Some of these substations are in extremely remote locations, and it can take hours for a response to an intrusion alarm. So for that reason, on these systems, we do need to have tamper-resistant screws interlocks that tell when a cover's been open, things of that nature. These substations also are very dirty. It's not like a data center where you have pristine, cool airflow. Some of these substations are in the desert areas. Some of them are in snowy areas. So the temperatures vary widely. So for that reason, we need systems that can survive in a variety of temperature ranges. One of the standards that we track to is the IEC 61850-3 standard, and it calls for a very wide temperature range of operating from minus 40 degrees C to plus 65 degrees C. So plus 65 degrees is really hot. Some of the substations do have air conditioning, but they also can run on batteries for up to 12 hours, and we don't run air conditioning on batteries, and there is no backup generation in the substation. So when there's a power failure, all we have is the batteries. With that as well, transient currents in the substation is a big problem. If one of these circuit breakers open on a 200 kV or 500 kV circuit, there's a big transient that goes through the power system. The system needs to be able to handle that transient without any data loss. So the standard that I mentioned does have provisions for that. Dirt is a problem, so the system needs to be well designed so that the system can stay cool, and even after 10 years being in that environment, still continues to operate.
There are definitely a lot of variables to factor in, and it's interesting when you think about all of the different aspects and potential risks, outcomes, and what burden that places not only on the common substation platform, but the grid itself. And so as the energy companies are embracing the viability and relevance of the common substation platform approach, what are the benefits that they should really be focusing on as they evaluate the implementation and application of this technology?
Utilities have to look from two angles. The first angle is what applications they are going to run at substations in future. We know all the applications have not developed yet, but with more and more renewables are penetrating at the edge of the grid, cars are getting electrified, that is going to change the dynamics. So once they understand that piece, what kind of infrastructure I need, that is where this next generation infrastructure will start enabling them. Build the infrastructure for once, and then you can next 10 to 15 years, you can keep adding your applications as needed. One example is that a edge ADMS, an advanced distribution system at the edge, it will automatically control the feeder, as Phil mentioned earlier. So that will help utilities to automate that process, and their control center system will become a system of systems.
Right, and Prithpal, here's the main problem that the utilities are facing. It used to be that the grid was stable because of inertia. Almost every source of power was a big rotating mass, and that was true for steam or gas or nuclear. A big turbine rotated and it generated electricity, and if there was a disturbance in the grid, that big mass kept on rotating. Now, with distributed resources coming on, like solar, like wind, they're connected to the distribution network instead of the transmission network. These are highly intermittent. So if you have a solar farm and a cloud goes over, generation stops. If you have a wind farm and the wind dies down, generation stops. So we have to have systems in place that can, at a moment's notice, deal with this and dispatch the energy to where it needs to go.
Exactly, Phil. That's what we call it active grid management. Grid need to be managed actively and probably many times per second. And we cannot bring all the data into a data center or a utilities distribution control center, process information and send it back. That all needs to happen at the edge.
Right. And it's only getting worse, especially in California, where there's a mandate to be at 100% renewables by 2045. And that's not that far off.
So with regard to the infrastructure side of things, the reliability, the longevity, durability that these common substation platforms will need to provide, talk me through the economic side of this whole transition and how that will play through for the utility companies as well as potentially the consumers.
We got to look from the two angles. First angle is the capital investment, and the second angle is operation and maintenance cost. From capital investment perspective, if you look at if utility have to buy 20 boxes, put in a substation, each box from multiple vendors coming there. So they have to deploy them. They have to keep some of them in the stock, and they have different versions of the hardware, different versions of the firmware. One utility told me that they have I think 200 different versions of the hardware and the 250 different versions of the software running in their system. So that is another itself is a nightmare to manage through it, and which costs a lot of money because you have to keep the spares, maintain them, roll the trucks to upgrade them. Then we come into the operational investment perspective. They basically know they have to manage each and every box individually. Each and every customer provides their own tool to manage it. Each and every vendor supplies its own tool to manage, configure, provision those boxes. Now utilities are facing two problems here. First, they have to keep multiple boxes, multiple tools, and then manage them one at a time. So if we flip the switch towards this virtualized world, and what happens, you standardize the hardware, you have rugged servers, and that's it. You have a centralized system to basically manage this standardized hardware, and everything else becomes the software applications. So in that, it saves them money on the capital cost, and also it saves them money on the operational cost side. In our analysis, the Intel worked with multiple utilities across the globe. We found out that there is a basically around 70% cost reduction with respect to operation and maintenance cost.
That's certainly very substantial.
Right. And part of the issue that we're seeing now as well is that because of the many different versions of equipment that's out there, most of these systems are connected by very high latency, low speed connections. Many utilities are not doing maintenance on the systems. They're not applying security patches, and some of these systems are vulnerable. Utilities are basically running this equipment until it breaks because they cannot afford to do the maintenance. It costs a lot of money to roll a truck with a crew to go out and take care of these things. So by building this virtualized, centrally managed system, we enable the maintenance, we enable cybersecurity, and make the system more robust and resilient.
So it's truly a longer-term, ease-of-use integrated system that benefits the utility company. It benefits the consumer from a consistency and availability perspective of not questioning availability of power as we continue to place greater burdens on the grid, correct?
I would agree with that.
Yep, 100%.
Wonderful. Well, given the need and the availability of the right technology and the compelling benefits, can either of you share and address any of the hesitations that energy companies might be weighing before they move forward with using a common substation platform?
Utilities are very hesitant to change. As you can imagine, there's great pressure on the people who maintain the grid to make the grid reliable. So the tendency is that the way that we did it last week, if it was successful, that's the way we want to continue doing it. So this is new technology to operational technology folks. They've not seen this before. They don't have the experience that IT folks have had in the data center. As Prithpal had mentioned, we've had this technology for a long time. So it's a big unknown to the people that are running the grid. We have to prove it to them that this technology works and could make the system more reliable and make their lives easier as far as maintaining it.
Yeah, how do we educate the utilities? So Intel works with the utilities to build a reference architecture. Let's take that reference architecture and implement that in their lab. And from their lab, let's take it to the pilot and go through that journey of learning, finding issues, fixing those issues, and building the awareness, capturing the data required for ROI analysis, and which will give the utilities confidence to move to the next level.
That's exceptional. And I think when it comes to, Phil, as you mentioned, embracing the unknown, that's a hard step to take. So it's really dependent, to Prithpal's point, about getting the education and the awareness, not just that the technology exists, but how it works and the ultimate benefits that it can bring forward. So it's moving forward with a level of confidence in the new technology and new applications. And I think that's an excellent point to tie off on here. Is we have to educate ourselves, our customers, our industries to reach that level of awareness so that we can effectively all move forward together. And that's how we'll get to a point of resolution on modernizing our overall smart grid.
Exactly.
I agree.
Prithpal and Phil, it's been an absolute pleasure talking with both of you. And your insight, your experience is incredibly helpful and beneficial to this conversation. And it's a big topic, so I have a feeling we will be revisiting this topic in the future. But again, thank you for joining me today, and hopefully we will be talking soon. And thank you to all of our listeners for joining in today. Be sure to visit crystalrugged.com/podcast and sign up to have new wrap sessions delivered directly to your inbox. And if you have a question about today's conversation or a topic you'd like us to cover in a future wrap session, just send me a message at info@crystalrugged.com. Otherwise, until next time, have a great day, and I'll wrap with you soon.